Hello, good afternoon. Welcome to this talk in the afternoon after lunch. My name is Florent. I'm a maintainer of the Vitess project, and I'm a software engineer at PlanetScale. And I'm with Matt, who is also a maintainer of Vitess and also a software engineer at PlanetScale. Today, we're going to give you a brief overview of what is Vitess, for those of you who don't know what it is yet. And then Matt is going to talk to you about resilience in Vitess. So let's start. What is Vitess? First of all, it's obviously a cloud-native project. We graduated, I think, in 2019. It was donated to CNCF by YouTube back then. And it is basically a massively scalable database. It is also it has like a very good high availability. And it is compatible with MySQL 8.0, MySQL 8.4. So you'll have basically two sides of Vitess. You'll have the operation side. So as an operator, you can very easily scale your database. You can manage it really easily. And you usually don't need that big of a team to manage your database, even though your database can be very big. On the other side, on the user side, it will feel like exactly like a normal MySQL, even though you have a lot of abstractions, you have a lot of new components. So you'll be able to use the same ORMs, the same applications. It will be the MySQL protocol. You'll have the same type of connection strings, everything. Like I say, we support the MySQL protocol. We also support the gRPC protocol if your application wants to talk in gRPC. Some of the core features that we have in Vitess are highlighted on that screen. And the first one, MySQL compatibility, we basically ensure that any queries you can run on MySQL, you can also run it on Vitess, even though you may have thousands of different shards. And then the other features are what differentiate us from just vanilla MySQL, I will say. So in Vitess, you can shard and reshard as much as you want. You can go from 0 shard to 2 shards and then 4, etc., etc. We support materialization workflows. So let's say you have, I don't know, 100 shards, and you have one queries that have to scatter on all of those shards, and it's a heavy one, and it just returns, let's say, like one number, one column. You may want to have a materialization workflow, which will basically keep that column updated in real time, so you never have to execute that query all the time, which will take time. You can just return the value that is stored in that materialized table. We also have cluster management, so you can easily do any type of operation, like if you wanted to promote a replica as the new primary. If you wanted to take a backup, restore, create a new replica, you can do that. Resharding as well is part of those cluster management commands you can have. We also support online schema changes with virtually no downtime. We also like throttle the online schema changes. So let's say you have one database that is kind of starving in terms of resources, we can throttle the schema change to avoid putting more pressure on your database that is already struggling. We also have obviously backup and recovery operations that also include point-in-time restore. And for instance, we have like a Kubernetes operator, which is called the Vitess operator. And in that operator, you can define a schedule, let's say every day or every week on Monday at 12 p.m. I want to take a backup of all my shards and all my key spaces. You can do that. We also have query consolidation. So let's assume all of a sudden you get like millions of queries that are targeting exactly the same shard, exactly the same data. Instead of sending that query, like those 1 million queries to the database, we're just going to send the query once and then return the result to the million requests that we got. That avoids putting way too much pressure on a database. And finally, we have automatic failure detection and repair thanks to VT.org. So let's say your primary goes down, we can automatically repair the situation by promoting one of the replica, and so on. We'll come back to this in a second. Before we keep going, a few items that we will talk about. In Vitess, we have key spaces, which is basically the same thing as a logical database in MySQL. In your cluster, you can have as many key spaces as you want. And each key space is going to be composed of one or many shards. And the shard is basically a subset of your data in your key space. A shard will contain one primary and then as many replicas as you want. And for us to know how do you want to divide your data, or like how you want to spread it across all of your shards, we have what we call a V schema. So your V schema is going to be like a big JSON object that will contain the mapping. So you will say, okay, I have my key space, I have shards in that key space, and I want that column in my table to be the one, like the values of that column will be defining where my data goes in which shard it will go. And the columns in a table, they can have a vindex, which is basically the same thing as an index in MySQL, and it will be useful for us to know how do we want to spread that data across the shards and in what way, basically. This is the architecture diagram. So if we start from the left, you have your applications, all your clients, and next to it, you have the load balancer. Your clients will connect to it via MySQL or a gRPC. And the load balancer will then send a request to the VT gate, which is the main entry point of the cluster. You can scale that layer as much as you want. So you can have one VT gate or you can have thousands of them to, like if you have a lot of queries, you may want to have more than one VT gate. And VT gate is going to do a lot of work. So it's going to get your queries, it's going to try to parse it, understand it, and then it's going to send the queries to the shards that you have, get the data out of the shards, and then it will do some aggregation if you need to do aggregation, and then all filtering, and then it will send it back to the client. And then a bit more on the right, we have the shards. So here we have 1, 2, 3, n shards. This is what's composing the key space. Each of the shards, like I said, you have one primary and then you have one or more replica. And we see VT tablet here. So VT tablet is the main component in a shard, well, we'll call that a tablet. So it's the main component in a tablet. That's going to shield MySQL with a lot of the work that it has to do. And this is what VTGate will connect to when it sends queries. So MySQL is basically a sidecar of VT tablet. In yellow, we have all of the administration layer. So you have VT admin, which is like a front-end UI where you can see your cluster, you can manage it, you can read and write your cluster. Then we have VT-org, which we kind of talked about before. It's going to repair the cluster if something goes wrong. So let's say here in one of your shards, the primary goes down, VT-org is going to contact the topo server. It's going to see the shard, the primary is no longer here, and then it's going to see, okay, which replica is available, which one has the least lag, replication lag, and then finally it's going to elect it as a primary. And we have VTCTLD, which is basically a daemon running all the time. It has an API, and then you can use that API to do all sorts of things in your cluster, like promoting a new primary, adding a new replica, etc. And in red, we have the topo server, which is, in most cases, will be etcd. Vitess is used in many, many places. You may recognize a lot of those names. If we focus on some of them, Slack, for instance, is running 100% on Vitess. So any message you send or you read from Slack is on Vitess. GitHub is almost the same thing. All of the issues, all of the pull requests is on Vitess. Vinted, for those of you that are from Europe, you may be familiar with it, but it's like a big online shop and they do over like 2 million QPS. And PlanetScale, we have like more than 10,000 different Vitess clusters from small to extremely large running in parallel. And to emphasize that a little bit more, so Slack, it's like way over 3 million QPS. They have a lot of shards, and sometimes they reshard, sometimes they decrease, increase. Square, which is the payment terminals, they have a huge amount of QPS as well. GitHub, same thing. And PlanetScale, in some of the databases that we host, we have like way over 10 petabytes of data, serving tens of millions of QPS. You have some links here later if you want to download the slides and just like read those posts if you want to learn more about the users. In regards to the community, we have a good community. We're a pretty stable project nowadays. We still have contributions from the outside, still have contributions from our core maintainers, obviously. Today is actually the 15-year anniversary, I believe, of the project. And yeah, I'll give it to Matt to talk about resiliency.
All right, okay, good, you can hear me. I'm glad everybody's over here because you get to see my good side or my least bad side. So thank you for that. So what does it mean to be resilient? We're going to talk about that and why it matters. So the first thing that you would probably think about is availability. This just gives you kind of an idea because we're going to talk about all the factors that go into this. Because of course, at first, if you ask anybody, they're going to say like, I want 100% uptime. But as we'll talk about, it's not practical for a number of reasons. The biggest one is ultimately cost, right? Because the cost, the human cost, the infrastructure cost is exponential as you go up this list. And is it worth it to your business? Is it worth $10 million in additional costs every year to go from 20 minutes of downtime throughout the course of the year to 5 minutes? Well, it may be, but those are practical considerations that have to come into play. So the first thing you have to do is really define what downtime is for you. There's the obvious ones of if your database is just returning errors on every query, that's a pretty simple one. But it can be much more complex than that. So typically you would define service level objectives, you would define set a P99 or P95 target. So that means like if 99% or 95% of my queries are executing within this window, whatever it is, let's say 2 milliseconds, then the service is up at 100%, it's operating at 100%. So those are more subtle things that you have to define. You may also have targets for the throughput that you can have, how many clients can connect, how many queries you can handle. So it's a little more nuanced that you might at first think about. So first you have to be able to define that and measure it. And then you have to define what is the cost to the business. What does it cost for every minute of downtime? And some of those will be pretty obvious. Like on average, we sell $10,000 worth of goods every minute or every hour. So that's pretty easy to break down. But there are other ones that are a little more subtle. So if you have an online service and you get a reputation for being unreliable, for not working when people really need your service, it may cost you your entire business. So there are more subtle things that you always want to keep in mind as well. And then once you've kind of figured those things out, then you have to figure out how are we going to meet those, right? So oftentimes personnel is an issue. Again, limited infrastructure that you can afford is an issue. And then another big one is just time to market, right? There's always a little bit of a trade-off between how important is reliability of our current service, which has a given feature set, versus getting new features or even new products to market as soon as possible. And so there's some trade-offs there to consider. I'm sure most of you are aware that we had a pretty big outage at AWS recently in US East 1. A lot of services are in US East 1. It's also an interesting thing for AWS in that it's kind of the way that they bootstrap the entire AWS service across the globe. And so it had pretty wide-ranging impacts. And this just gives you some ideas. These are estimations of how much it costs per hour of downtime for these organizations. So in pure dollar numbers, it's quite significant. So what faults do we care about, right? If you're relatively new to computers, or you haven't operated at a certain scale, you might say, well, like, I've had this computer running in my closet for 10 years. Nothing's ever stopped working, right? The disk is still working, et cetera. But once you get to a certain scale, you see failures in components that you didn't even know existed, right? You didn't even know was part of your system. I've been in this business for getting close to 30 years now. I started in the 1900s, right? And I'm still surprised every day by all the new sets of failures I get. If you think about all of the hardware and software components that you have, which make up your entire system, all the way down to network cards, for example, the microcode on the machine, these things fail, and they have bugs. And so when you factor in the whole topology that you have of all of these hardware and software components, you are going to have failures, and they are going to happen every day. So how do you maintain your reliable service in the face of all these failures? So that's where resilience comes in. So we're going to talk about some principles and specific features which allow Vitess to be resilient in the face of these failures. So a big one is isolation, right? You want to avoid single points of failure whenever you can. And part of that feeds into redundancy, right? So you want to have redundant components, just like in an airplane, right? If one engine goes out, it's pretty nice to have the second one, right? That's right there to take over, and that can get you where you need to go, without hitting the ground a little faster than you would like. So being able to degrade performance when possible, so that you can still service all of your requests, but within a reasonable time frame, is ideal. So anytime you can handle every user request, even if it's slightly more latent than it normally would be, those are important behaviors to have in your system. But at some point, you will need some circuit breakers in there, because at some point, there is a limit to how many requests that your service can handle. And so you need to be able to detect when that happens, and then take steps to ensure that the service as a whole remains up and remains serving. Automated recovery, of course, is a big part of that. So you want to be able to have a relatively small team that's managing this large scalable backend. And so you want as many things to be automated as possible, right? It takes a long time. If a primary goes down, somebody gets a page, they've got to go to their laptop, they've got to look at the system, they have to promote one of the replicas. Like, that can take 5, 10, 15 or more minutes. So being able to have those things automated is a key part of having a resilient service. Observability is a key one. So what you really don't want to have happen is to be sitting at work thinking everything is good, and then a customer calls you and says, what is going on? I can't use your service. You don't want to be alerted to service outages by your users. So you want to have good observability, so that not only are you aware of current issues, but so that you become aware of pending issues, right? You want to know if query times are slowly increasing, or maybe you need to scale up one of your shards, for example. And then testing is just kind of a fundamental thing that gives you confidence that when things do happen, the systems that you have in place will be able to handle that. So we'll go a little bit more on each one. We got about 10 minutes left. I'll try to be mindful of time. So we talked about isolation. So the biggest thing is spreading each of those components out so that you can isolate failures as much as possible. The last thing you want is everything to be on a single machine, right? So you don't want everything to be on a single machine. You don't want everything to be in the same data center, right? Because then you can have an availability zone that goes out. So you want to have each of your components spread out across availability zones typically. So you would typically pick whether it's US East or US West or something in Europe, and then you would spread those components out across the availability zones within that area. You want to have stateless services as much as you can. So Kubernetes really shines when you have stateless services. So in Vitess, that's VT gates. And that allows you to scale those very simply. It's dead simple to scale stateless services. So you can set up the horizontal pod autoscaler, for example, so that when the average CPU usage goes above a certain level, you can automatically have more of those spun up. Anything that you can have outside of your hot path, if you will. So the path that every request is going to take from a user, the more that you can have outside of that, the better. And so in Vitess, we have the topology server, which Florent touched on. And that is not part of the query hop path. So you can continue to serve queries if for some reason your entire etcd cluster goes down, for example. And then being able to, again, shard your data so that you have redundant copies of each subset of your data that can then take over for if any failure happens is obviously a pretty key one. And that feeds into redundancy. We use semi-sync for writes. So what that means is that anytime a customer of yours gets a confirmation like, hey, your order has been placed, that only happens once that order is durable across multiple machines, across multiple tablets. And for the topo server, I think we already talked about that. Everybody has probably heard of etcd. Of course, it's a key part of Kubernetes itself, but that's also used as the kind of the coordination and locking service. And again, you would typically have at least 3 nodes because there's a majority quorum, so 3 or 5, depending on how resilient you want to be to multiple failures. And those be spread across the availability zones. For the graceful degradation of service, remember this is where you want to be able to handle all of the requests that come in whenever you can with a slightly elevated latency. So that's kind of the optimal case. Before you get to the point where you have to initiate some circuit breakers just to protect the service itself. So it doesn't do you or your users any good. Let's say you have a million requests a second, right? So you have a million customers, let's say, that are asking you for something every second. It's much better to have a very tiny percentage of those requests fail than to have try to service all of them beyond a certain point and the entire thing falls over. So that's what I mean by the circuit breakers. And these are just a sampling of some of the features that Vitess has. We already talked about query consolidation. So again, you would often, it's common to shard all of your data by customer ID, let's say. So this customer's data is all on this one shard, so you have good data locality. And if that customer is suddenly in the news, hopefully for a good reason and not a bad reason, but if they're suddenly in the news and you hit like 1 million people that are like, oh my God, I need to know this bit of information about customer 1, whoever that is, we can just execute one query on the database. So that thundering herd of requests that come in, or that hot row, that you have in the database only needs to execute the query once, and then everybody can get the same result back from that. A key part of having failure detection that's automatically addressed, a key part of that, a key desirable property of that is that all of that is invisible to your users, that they're not aware that you had some node TTL that happened. They don't really care. They just don't want to see any impact from that. So VT gates will also buffer requests. So VT gate will see when, so VT-org has noticed that, hey, this thing has failed. It'll issue or start a recovery, automated recovery and failover. VT gate will see that that's in process. It will start buffering the queries that are coming in that are targeted at that shard. And then once the new primary has been promoted, all those queries will go through. So again, that's a good example of graceful degradation. There's a slight latency there. Most of those failures will be sub-second. So there'll be a slight period of elevated latency, but they won't see any errors from that. All right, I'm gonna have to pick up the pace a little bit. So we've talked about automated recovery a bit. Just to highlight some things, so VT-org is the main thing that's monitoring the entire cluster, along with the Kubernetes operator, if you're using Kubernetes, which probably most people here are, I would imagine, since we're at KubeCon. But those two are the things that will be kind of monitoring the state of the cluster and ensuring that everything is healthy, everything is serving. But VT-org is the one that will make the ultimate decision if there needs to be a failover. And it will talk to the replicas just to make sure and try to form a consensus of what the view of the state of the world is, and see if, ensure that the replicas also can't talk to the primary, and it's not just VT-org that can't talk to it. Because each individual component may become isolated on the network, You may have network partitions. And so that's just an example of kind of the more intelligent behavior that Vitess has for handling failures. Oh, I've already talked about this. We don't really need to spend any time on it. As I mentioned, you want to be able to scale your database layer and also scale your operations team, because cost is always a huge factor in any business. In order to do that, you want to have as small a team as possible. So a big part of that is telemetry that people can build on, so that you can. So most of the time, or hopefully, and in typical cases, there's not going to be any issue. And so this staff can be off doing other things, and you want to be able to then set up automated alerts for when there's an issue or there's a trend that looks like it's going to turn into an issue, so that they can get an alert and they have enough time to investigate it, ideally, before an actual customer affecting or visible issue occurs. Testing and benchmarking, this is, again, a pretty obvious one. Vitess has performance benchmarking. So there's performance benchmarking, there's correctness benchmarking. Both are important, because if a system serves you the correct answer, but does it so slowly that you don't see it for one reason or another, or by the time you get it, you don't care for one reason or another, it's useless. So it may not be obvious, but performance testing is also a critical component. And so we do that per release. When we have a PR that we think it may impact performance, we can also flag that, and we'll do it per PR as well. And that really gives us the confidence. It gives you the confidence to operate it, to upgrade, but also it gives us the confidence to ship new features quickly in Vitess, which is another thing that may not be quite as obvious as testing. But when you have a big, complicated distributed system, a really good test suite is what gives you confidence to ship a new feature and know that it's not going to cause unexpected issues elsewhere. All right.
All right. We have a brief summary. I'm gonna go fast because we're almost out of time. But like Matt talked about, one of the main things to keep in mind is that with Vitess, you can very easily have multiple shards. In each of the shards, you're gonna have multiple tablets. So you're gonna have your primary, your replicas, and you will want to put those in like different availability zones. So like if something happens to your zone, you'll be fine. The fact that you have a primary and then multiple replicas, it allows you to very quickly fail over if something happens to your primary, and then you can keep serving writes. And then the big part that makes Vitess resilient, obviously, is going to be the orchestrator and the operator, like on Kubernetes, which will do a lot of the logic. Like if something goes bad, it will recreate it, it will replace it, etc., etc. And like we didn't really talk about it, but we also have the replication, which is like the whole thing about online schema changes, etc., etc. Yeah, that's it for us. If you have any question, if you want to talk to us, you're welcome to do so. We're on Slack, or we can just talk right after the talk. And yeah, I think we have a birthday party in like less than an hour. So if you want to come to the project pavilion downstairs, we can talk there as well. You have more resources here. If you download the slides, you can check them out. And thank you.
Any questions? If you do have questions, just use the mic, because then it will become part of the recording and everybody will know the question that we're answering. But also feel free to come up to us after and just have a direct chat. Or we'll be back at the booth tomorrow morning as well. All right. Thanks, everybody. Well, enjoy the rest of your conference. I hope you make it home on time and safely.